My name is Don Herbert. Many of you may have grown up knowing me by another name, Mr. Wizard. I've spent the last 25 years or so explaining how the most remarkable things in the world are really quite simple in principle. Now, the same is true about Pioneer's LaserDisc player and the whole concept of a laser disc. On the other side of this demonstration disc, you found out about the fact that Pioneer's disc player is based on the laser, so perhaps the place to start is, what is a laser? Well, the word laser is an acronym for light amplification by stimulated emission of radiation, laser. I'd like to think of it this way. Here is ordinary light, made up of waves of many different lengths going in all different directions. But laser light is made up of waves of one single wavelength, and while engineers call it coherent, I like to think of them as in step. And the fact that laser light is in step means it can be focused to a much greater degree than normal light. In fact, here's normal light. And as you know, with a lens, you could focus it down to a tiny spot like that. If this were laser light, that spot would be 1/10,000th this size. There's another remarkable thing about laser light. It's capable of carrying enormous amounts of information simply because the light is of such short wavelength. Here, I'll show you. Let's assume this is the information that you want to send out over electromagnetic waves. Here's a carrier of relatively long waves. That's the amount of information it could carry. Here's a carrier of much shorter wavelengths. See, the long waves missed some of the information, while the shorter waves carried much more of it. In other words, the shorter the wavelength, the more information it can carry, and the greater detail. And a laser beam is of such short wavelength, it can carry unbelievable amounts of information. In fact, theoretically, one laser beam could carry all the telephone calls and all the radio and television programs in the United States all at the same time. That's one of the reasons Pioneer chose a laser to read the information on the disc. Well, let's look at the actual laser beam as it appears inside the Pioneer LaserDisc player. We've exposed the beam itself so that you could see it better. Now I'll add a little CO2 fog. See it? In the Pioneer player, the laser beam is emitted from a helium neon laser tube that looks like this. Looks sort of like a fluorescent lamp, doesn't it? In this drawing, that's the laser tube. From it, a single laser beam passes through a grating that breaks the beam up into several beams. 3 of them then pass through a prism and are guided by 2 mirrors and a lens that focuses the beam down to 1/30,000th of an inch onto the reflective surface of the laser disc itself. Then microscopic pits on the surface interrupt the beam and reflect some of it back through the mirrors. When the reflected beam reaches the prism, it's deflected onto a device that converts the optical beam into a frequency-modulated signal that contains both the sound and picture information. The same information that was encoded on the disc when it was made, from an original signal to an optical signal to a reproduced signal. That's the whole remarkable idea behind the laser disc. It's as simple as that. Now, one of the questions people often ask is how a disc that's traveling at 1,800 revolutions per minute retains such remarkable picture resolution and sharp focus. Well, it's all a matter of mirrors, 2 of them as a matter of fact. A tangent mirror and a tracking mirror, and an objective lens that's moving up and down hundreds of times a second. See, when the laser beam is split by the grating, it's broken up into 3 beams. The center beam reads the information. The 2 adjacent beams are what keep the whole system on track. As the disc spins, any slight up and down motion is sensed, and the objective lens is moved up and down to keep that center beam in perfect focus automatically. When it's centered, it looks like this. Notice the position of the 2 tracking beams. Now, if it gets just the slightest bit off center, like that or like this, there's a big difference in the amount of light reflected by the tracking beam. And that difference is sensed by a photocell, which adjusts the tracking mirror to bring it back on center again. Wow and flutter in the disc is virtually eliminated in the same manner by the tangent mirror. All this happens automatically at 1,800 revolutions per minute. Now, the remarkable picture and sound quality that's on the disc is there permanently. And unlike a phonograph record, it can't be damaged by handling. Here's some chocolate ice cream. Yeah, it's chocolate, all right. Do this to a phonograph record, and it would be goodbye sound quality. With the LaserDisc, simply wipe the disc clean, and it's as good as new. It's easy to understand why. Here's a much enlarged model of the disc, and here it is in cross-section. You see, the reflective surface that contains the video and audio signal is covered by a layer of protective clear plastic. The laser beam focuses only on the reflective surface. The surface of the plastic is out of focus, therefore anything on it isn't picked up. Dust, fingerprints, and even minor scratches don't affect the exceptional sound and picture quality on the disc. Now, many of the benefits of the LaserDisc come from the unique feature of variable slow motion, both forward and reverse, and a stop motion that remains frozen indefinitely without any damage to the image. Now, as you know, this is impossible with videotape, since the spinning video head would in time wear out the tape. These features make the Pioneer LaserDisc player a remarkable educational tool that allows you to study the picture at your own rate and repeat information as often as you need it. It also allows discs to be used by classes over and over again without any wear. The unique optical system allows the laser beam to jump from track to track, thus creating different speeds. This spiral represents several tracks on the LaserDisc. One track consists of two fields. In other words, the TV picture is scanned from top to bottom twice during each revolution of the disc, here and here. So each revolution of the disc produces one picture on the TV screen. In normal play, there's no track jumping. The beam merely follows the spiral track from the inside to the outside. In reverse motion, the beam jumps back one track after each field, one here and one here. So at the end of each revolution, the beam is one track behind where it started. One forward, two back. Fast forward is exactly the opposite. The beam jumps forward one track after each field, so after each revolution, the beam is actually 3 tracks further ahead than it was. And that's why fast forward on the Pioneer player is not twice, but 3 times the speed of normal play. Now, a still frame is produced by continuously repeating one track. The track is read, and then the beam jumps back to repeat the same track. Slow motion is simply a series of still pictures. The longer each still stays on, the slower the motion. The slow motion slide control lets you determine how long each picture remains on the screen until the beam continues on to the next track and creates the next still picture. Slow motion reverse is the same principle, except the picture jumps back one track. A unique feature of the Pioneer LaserDisc player is random access that lets you search out any frame on the disc. Each frame on the LaserDisc is coded with a 5-digit number. As the disc spins, the laser beam jumps from track to track and reads the code. You can find any frame on a half-hour disc in less than 20 seconds. Another remarkable thing about the Pioneer system is the audio fidelity that laser technology achieves. To those of you who understand the specs, the numbers will explain the whole thing. The LaserDisc contains 2 independent audio subcarriers, each modulated to plus and minus 100 kilohertz deviation. Since no stereo decoding is required, the audio information has none of the high-frequency problems inherent in conventional stereo broadcasts. The LaserDisc player will give you a frequency response of 40 hertz to 20 kilohertz. The signal-to-noise ratio is 55 dB or more. Total harmonic distortion is no more than 0.3%. The LaserDisc is certainly a substantial improvement over FM radio reception. And if you hook it up to a hi-fi system, well, as you heard on the other side of this demonstration disc, it's light years beyond what you receive from your standard TV set. Not only is the audio fidelity better on a LaserDisc, but the video resolution is substantially better than any other kind of home video playback system. Think of resolution this way. On a still photograph, the number of dots in a given area determines the resolution and the brightness and the clarity. The greater number of dots, the higher the resolution. The same principle applies to a television screen. The greater number of lines, the greater the resolution. And Pioneer offers more lines, far more resolution than any other home video system. As unbelievable as it seems, 40% higher resolution than a home video cassette player. So now you know the whole logic behind the LaserDisc. But the remarkable part is not merely how the LaserDisc system works, but what it brings you. A world of entertainment and information without limit. This is Don Herbert for the LaserDisc player from Pioneer.